The first one we'll talk about is autoignition theory. And basically, autoignition, any combustible air fuel mixture, if you subject it to a high enough temperature for a long enough period of time, it will go through some precursor chemical reactions and autoignite. And that can be tested in a setup like a rapid compression machine, where you can compress the mixture to a high temperature and pressure. And from that, you can record the autoignition delay time for that given mixture, temperature, composition, and pressure. So in the autoignition theory, as the flame is progressing across the combustion chamber, it is compressing and heating the end gas, or the last mixture to burn on the far side of the combustion chamber. And it compresses that to a high enough temperature and pressure that that mixture can then self-ignite or autoignite. That autoignition results in, because it's gone through these precursor chemical reactions, results in a very rapid heat release rate in that end gas, and that ends up creating a very high localized pressure that we end up hearing or determining as knock. So next slide. The other theory out there is detonation theory, and this is fundamentally different. This says that under knocking conditions, the conditions, again, mixture concentration, temperature, and pressure are such in the combustion chamber that the advancing flame front will accelerate to basically sonic and supersonic velocities and then consume the remaining mixture at a much faster pace than the normal flame speed, which would result in the same kind of rapid heat release and pressure spike. And that theory has led many to call knock by the term detonation. There have been a lot of photographic studies, simulation studies, and things over the years that have shown that typical SI engine knock is really end gas autoignition and not detonation. So detonation is a real thing, comes into play in terms of explosives and those kind of things, but generally it's not supported by the studies as the fundamental cause of knock. There are some cases in a later part of the course, we'll talk about stochastic preignition and super knock, which is a more recent phenomenon in boosted engines. And in those cases, there is some evidence that we are seeing developing detonation. But for normal SI combustion, it's really end gas autoignition. If we go to the next slide, this kind of shows what we're talking about. This is a optical engine still photograph taken of a combustion process. In this particular image, the burned gas is the darker region, and the lighter colored is the unburned or end gas portion of the charge. And you can see the spark plugs down in the kind of 4 o'clock position, the flame initiated there, it's moving its way across the combustion chamber, and out in front of that propagating flame, you see some dark patches that show up, and those are autoignition sites. So this is the start of the knock event on this particular cycle.